So the question is solved by simplex method. Maximize z equals 16x1 plus 17x2 plus 10x3 subject to x1 plus x2 plus 4x3 less than or equal to 2000. 2x1 plus x2 plus x3 less than or equal to 3600. x1 plus 2x2 plus 2x3 less than or equal to 2400. x1 less than or equal to 30. x1 comma x2 comma x3 greater than or equal to 0. So this is our question. So first we form the standard form of the above equation. So we write it as standard form of the equation. So standard form of the equation is given by maximize z equals 16x1 plus 17x2 plus 10x3 and subject to constraints we change all the less than or equal to sign into equal to sign by adding a slack variable, that is s. So first one, x1 plus x2 plus 4x3 plus s1 equals 2000. Next one, 2x1 plus x2 plus x3 plus s2 equals 3600. Next one, x1 plus 2x2 plus 2x3 equal plus s3 equals 2400. Next is x1 plus s4 equals 30. x1 x2 comma x3 comma s1 comma s2 comma s3 greater than or equal to 0. So as we have added this here, so we add s1 s2 s3 and s4 in the subject. So here we add 0 s1 plus 0 s2 plus 0 s3 plus 0 s4. So using the standard form we will be making a simplex table. So we form the initial simplex table. So starting is basic variable, that is BV, then CB, coefficient of basic variable, then XP, that is solution. Then we have x1, x2, x3, then we have 4 slack variables s1, s2, s3 and s4. Then we have minimum ratio, that is xb by xi. Then we write the value of Cj. The value of Cj's are 16, 17, 10, 0, 0, 0, 0. Then we write the basic variables. From each constraint, we have 4 constraints, right? So from each constraint, we choose one basic variable. So the basic variable in the first constraint is S1, in the second constraint is S2, third constraint is S3, and fourth constraint is S4. So next is CB. The coefficient of the basic variable S1 is 0. Coefficient of S2 is 0. Coefficient of S3 is 0. Coefficient of S4 is 0. Then the value of XB, the first constraint is 2000. In the second constraint, it's 3600. The third constraint is 2400. The fourth constraint is 30. So the value of x1 in the first constraint, that is coefficient of x1 in the first constraint is 1, x2 is 1, x3 is 4, s1 is 1, s2 is 0, s3 is 0, and s4 is 0. Then in the second constraint, the value of x1 is 2, x2 is 1, x3 is 1, s1 is 0, s2 is 1, s3 is 0, s4 is 0. Then in the next constraint, the value of x1 is 1, x2 is 2, x3 is 2, s1 is 0, s2 is 0, s3 is 1, s4 is 0. Then in the next constraint, the value of x1 is 1, the x2 is 0, x3 is 0, s1 is 0, s2 is 0, s3 is 0, and s4 is 1. So next, after this, we'll calculate the value of Zj. So how we calculate the value of Zj? It's Cb into x1, that is 0 into 1 plus 0 into 2 plus 0 into 1 plus 0 into 1, that is 0. Next, 0 into 1 plus 0 into 1 plus 0 into 2 plus 0 into 0 is 0. Next is 0 into 4 plus 0 into 1 plus 0 into 2 plus 0 into 0 is 0. Next is 0 into 1 plus 0 into 0 plus 0 into 0 plus 0 into 0 is 0. Next, 0 into 0 plus 0 into 1 plus 0 into 0 plus 0 into 0 is 0. Next, 0 into 0 plus 0 into 0 plus 0 into 1 plus 0 into 0 is 0. Next, 0 into 0 plus 0 into 0 plus 0 into 0 plus 0 into 1 is 0. So we have calculated the value of Zj. So next we calculate the value of Cj minus Zj. The value of Cj is 16, 17, 10, 0, 0, 0 and 0. So here Cj minus Zj we calculate by 16 minus 0, that is 16. Next is 17 minus 0 is 17. Next, 10 minus 0 is 10. 0 minus 0 is 0. 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 So we have obtained the value of Cj minus Zj. Here the value of Cj minus Zj is not less than or equal to 0. Therefore, the solution is not optimal. So we have, since the solution is not optimal, we have to form another simplex table. So for that we take the maximum value in Cj minus Zj. Which is the maximum value? It is 17. 17 is the maximum value. So this is the key column. So this is the key column. So next we have to find the key row. For that we calculate minimum ratio of xb by xi. What is xb? This is xb. 2000, 3600, 2430 is the xb. What are xi's? 1, 2, 1, 1, 2, 0 are the xi's. So we calculate xb by xi is 2000 divided by 1 equals 2000. Next is 3600 divided by 1 is 3600. Next is 2400 divided by 2 is 1200. Next is 30 divided by 0 is not defined. So which is the minimum value here? Minimum value is 1200. So we can't take this thing because it's not defined. 30, any value divided by 0 is not defined. So we take this as the minimum value. So this forms the key row. So the intersection of key row and key column is the key element. So this is the key row and this is the key column and this is the key row, and this forms the key element. Okay, so the next step is the formation of next simplex table. So for that the key element should be equal to 1 and the values above and below the key element should be equal to 0. Is that clear? We have to make this value as well as this value to 0. So we form another simplex table. So first, for that we calculate the, consider this as R1, R2, R3 and R4. Okay, so first we have to convert this key element to the value 1. So R3 new equals R3 old divided by 2 key element. So that is, what is R3? R3 is 2400, 1, 2, 2, 0, 0, 1, 0 divided by 2. So which gives R3 new equals 1200, then 1 by 2, 1, 1, 0, 0, 1 by 2, 0. So this is the new R3. Then next, we calculate the value of R1 new. What is R1 new? R1 new is R1 old minus R3 new. What is R1 old? R1 old is this one, 2000, 1, 1, 4, 1, 0, 0 and 0. What is R3 new? R3 new is this one, is 1200, 1 by 2, 1, 1, 0, 0, 1 by 2, 0. Okay, so put a minus symbol here. So R1 new equals 2000 minus 1200 is 800. 1 minus 1 by 2 is 1 by 2. 1 minus 1 is 0. 4 minus 1 is 3. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 by 2 is minus 1 by 2. 0 minus 0 is 0. So this is the new R1. So we have calculated the value of new R3, new R1, and next we calculate the value of R2. This new R2, that is R2 new equals R2 old minus R3 new. What is R2 old? R2 old, the value is 3600 to 1, 1, 0, 1, 0, 0 is the value of R2 old. What is the value of R3 new? R3 new is 1200, 1 by 2, 1, 1, 0, 0, 1 by 2, 0. So this is the value of R3. So we calculate new R2 by subtracting R2 old from R3 new. Okay. So 3600 minus 1200 is 2400. 2 minus 1 by 2 is 3 by 2. 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. 0 minus 1 by 2 is minus 1 by 2. 0 minus 0 is 0. So this is the new R2. So next, the value of R4. R4 new is equal to R3 old itself. Why? Because if you see here, the value of R4, the value below 2 is already 0. So we don't have to change this into 0 because it's already 0. Here the values was 1 and 1. So we did the calculations so that this one is changed into zeros. So here R4 new is R3 old. So we have calculated the new values for the new simplex table. So next is simplex table 2. For that, first we calculate VV basic variable, CB coefficient of basic variable, and XB. Okay, forgot to mention one thing here in this, the value in the key column comes in, that is x2 comes in, and value of key row goes out. Okay, that is x2 comes in and s3 goes out, because this is the key row, this is the key column. So here VB, CB, XB, X1, X2, X3, S1, S2, S3, S4, minimum ratio. Okay. So the variables are S1, S2, X2, S4. The value of CB is 0, 0, 17, 0. The solution variable is 800, 2400, 1200 and 30. The value of here is 1 by 2, 0, 3, 1, 0, negative 1 by 2, 0. So right, this is the R1 values, right? We have seen here, right, this value, this is the R1 values. So next is value of the second row, that is R2 new. Their values are 3 by 2, 0, 0, 0, 1, negative 1 by 2, 0. Next it's 1 by 2, 1 1 0 0 1 by 2 0. Next it's 1 0 0 0 0 0 and 1. So next we here write the values of Cj, the same like in the previous simplex table, that is 16, 17, 10, 0, 0, 0 and 0. So next we calculate the value of Zj. How we calculate the value of Zj? It's Cb into 1 by 2 plus 0 in, that is 0 into 1 by 2 plus 0 into 3 by 2 plus 17 into 1 by 2 plus 0 into 1, which is 17 by 2. Next is 0 into 0 plus 0 into 0 plus 17 into 1 plus 0 into 0 is 17. Next 0 into 3 plus 0 into 0 plus 17 into 1 plus 0 into 0 is 17. Next 0 into 1 plus 0 into 0 plus 17 into 0 plus 0 into 0 is 0. Next 0 into 0 plus 0 into 1 plus 17 into 0 plus 0 into 0 is 0. Next 0 into negative 1 by 2 plus 0 into negative 1 by 2 plus 17 into 1 by 2 plus 0 into 0 is 17 by 2. Next is 0 into 0 plus 0 into 0 plus 17 into 0 plus 0 into 1 is 0. Next we calculate the value of Cj minus Zj. So Cj minus Zj is 16 minus 17 by 2 is 15 by 2. Next 17 minus 17 is 0. Next 10 minus 17 is minus 7. Next 0 minus 0 is 0. Next 0 minus 0 is 0. Next 0 minus 17 by 2 is negative 17 by 2. 0 minus 0 is 0. So here Cj minus Zj, this value 15 by 2, Cj minus Zj is not less than or equal to 0. Therefore the solution is not optimal. So what is the next step? The next step is we calculate the maximum value in Cj minus Zj. So which is the maximum value here? Maximum value is 15 by 2 is the maximum value. So this would be the key column. And we calculate the minimum ratio. How we calculate the minimum ratio is, it's Cb by Xi. So it is 800 divided by 1 by 2 is equal to 1600. Next is 2400 divided by 3 by 2 is equal to 1600. Next is 1200 divided by 1 by 2 is equal to 2400. Okay. Next is 30 divided by 1 is equal to 30. So here 30 is the minimum in the minimum ratio. This is 1600, this is 1600, and this is 2400, and this is 30. So which is the minimum value? 30 is the minimum value. So this is the key row. So this is the key row and this is the key column, and the intersection is 1. So this is the key element. So here the value of x1 comes in and the value of s4 goes out. Okay, so the value of x1 comes in and the value of s4 goes out. So next we have to calculate. So we have to form the next iteration table, as this is not optimal. So next step is to make the values of 1 by 2, 3 by 2 and 0, 1 by 2 into zeros. For that, since this value is already 1, we don't have to do any alteration in this row. That is, if you consider it as R1, R2, R3 and R4, R4 new is equal to R4 old divided by 1. That is the same value. It's 31, 0, 0, 0, 0, 0 and 1. So this is the new R4, which is same as this. Okay, so in the next we calculate for R1 new, which is equal to R1 old minus 1 by 2 R4 new. Okay, what is the value of R1 old? R1 old, the value is 800, 1 by 2, 0, 3, 1, 0, negative 1 by 2, 0. What is 1 by 2 into R1 new? It is 60. 1 by 2 into R4 new, it is 15. 1 by 2, 0, 0, 0, 0, 0 and 1 by 2. This is the negative sign. Okay, so here the values are 785, 0, 0, 3, 1, 0, negative 1 by 2, negative 1 by 2. So this is the new R1. Okay, next we find the value of R2. R2 new is equal to R2 old minus 3 by 2 R4 new. Okay, what is R2 old? R2 old is 2400, 3 by 2, 0, 0, 0, 1, negative 1 by 2 and 0. That is 3 by 2 into, next is calculate the value of 3 by 2 into R4 new. That is that is 3 by 2 into 30 is 45. Next is 1 into 3 by 2 is 3 by 2. Next is 3 by 2 into 0 is 0. 3 by 2 into 0 is 0. 3 by 2 into 0 is 0. Then 0 into 3 by 2 is 0. Then 0 into 3 by 2 is 0. And 1 into 3 by 2 is 3 by 2. So we get R2 new, which is equal to 2355 0 0 0 0 1, negative 1 by 2, negative 3 by 2. This is a minus. Okay. This is R2 new. Next we calculate the value of R3 new, which is equal to R3 old minus 1 by 2 R4. So what is R3 old value? It is 1200, 1 by 2, 1, 1, 0, 0, 1 by 2, 0. Okay, next what is 1 by 2 R4? 1 by 2 R4 is given by 15. 30 divided by 2 is 15. 1 divided by 2 is 1 by 2. 0 divided by 2 is 0. 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 1 divided by 2 is 1 by 2. So we get the new R3 new, right, minusing this. So the value will become 1185 0 1 1 0 0 1 by 2, then negative 1 by 2 minus 0 is 1 by 2, 0 minus 1 by 2 is negative 1 by 2. So this forms the R3 new. So using this R1 new, R2 new and R3 new and R4 new, we formulate the new simplex table. So this is simplex table 3. So in that we calculate dv, cv and xp. Next is x1, x2, x3. This s1, s2, s3 and s4. Which is minimum ratio is xp by xr. Okay. So the new basic variables are s1, s2, x2 and x1. This is why, because here s4 goes out and x1 comes in. So values of CBs are 0, 0, 17 and 16. The value of XB is 785. This is the new row. We write it in this order: 785, 0, 0, 3, 1, 0, negative 1 by 2, 1 by 2. Next is R2 new is 2, 3, 5, 5, 0, 0, 0, 0, 1, negative 1 by 2, negative 3 by 2. Next is R3 new, that is 1, 185. This 0, 1, 1, 0, 0, 1 by 2, negative 1 by 2. Next is R4 new is 30, 1, 0, 0, 0, 0, 0, 1. Values of CJ are 16, 17, 0, 10, 0, 0, 0 and 0. So next we calculate the value of Zj. So we calculate Zj, 0 into CB into xi, that is 0 into 0 plus 0 into 0 plus 17 into 0 plus 16 into 1 is 16. Next is 0 into 0 plus 0 into 0 plus 17 into 1 plus 16 into 0 is 17. Next is 0 into 3 plus 0 into 0 plus 17 into 1 plus 16 into 0 is 17. Next is 0 into 0 plus 0 into 1 plus 17 into 0 plus 16 into 0 0 into 1 plus 0 into 0 plus 17 into 0 plus 16 into 0 is 0. Next is 0 into 0 plus 0 into 1 plus 17 into 0 plus 16 into 0 is 0. Next is 0 into negative 1 by 2 plus 0 into negative 1 by 2 plus 17 into 1 by 2 plus 16 into 0 is 17 by 2. Next is 0 into 1 by 2 plus 0 into negative 3 by 2 plus 17 into negative 1 by 2 plus 16 into 1. So we get 15 by 2. Next we calculate the value of Cj minus Zj. What is Cj minus Zj? 16 minus 16 is 0. 17 minus 17 is 0. 10 minus 17 is negative 7. This 0 minus 0 is 0. This 0 minus 0 is 0. 0 minus negative 17 by 0 minus 17 by 2 is negative 17 by 2. 0 minus 15 by 2 is negative 15 by 2. So we can see the value of Cj minus Zj is less than or equal to 0. Therefore, the solution is optimal. So from this we can calculate the value of, we get the value of x1 as 30 and x2 as 1185. Therefore x1 equals 30 and x2 equals 1185. Therefore Z max equals 16x1 plus 17x2 plus 0s1 plus 0s2 plus 0s3 plus 0s4 equals 16 into x1 is 30 plus 17 into x2, 17 into 1185 plus these values become 0 as 0 into anything will be 0. The value of S1 here is 785, but 0 into 785 is 0. The value of S2 is 2355, but 0 into 2355 will be 0. So the value becomes 0. The S3 equals 0 and S4 equals 0. So the value becomes 0. So this value in total becomes 0. So multiplying this and adding, we get the value as 20,625. So hope you have understood how to find the optimal solution using simplex method. Thank you.